and then hand it up. So we both Owen and I experienced the phenomenon here. I got some emails last night and some emails this morning. Dr. Ashbrook, I'm not sure, I'm confused on the homework, I don't know how to do it. And so then there was some scrambling this morning, is that correct? To get it done. So you got to start early so you can have time to think and then get your questions answered. So I was in my office yesterday during office hours from 10 to noon, and then most of the afternoon I was also there just being around. So, and this was posted Friday. This homework was posted Friday. So if you tried to start last night, then you probably weren't able to get the help you needed, okay? So start early so you have time to think and really work at it, and then you'll still have time to consult with us, okay? And get questions answered. So the purpose of the homework is really to understand these ideas, right? So homework in previous math classes may have been more like drill and practice, like you're just doing the same methods and procedures that the teacher did, just over and over again. That's not what this class is going to be like. The homework is going to be about causing you to think and to work on your understanding of ideas, okay? So you're going to need time for that, and then you're going to need time to talk to us. Does that make sense? So, lesson learned for those who got started too late on this. Let me do the first couple parts of this using the type of reasoning that that we've been talking about. So what I did on my computer screen, I measured the width of the sidewalk at the base of the truck and the width of the blur. And I got 9 centimeters. So on the way it was on my screen, I measure that to be 9 centimeters. Is that showing up in red? Kinda. Is blue better? Is black better? Oh, I could do white, but it's really thick. Let's do white. Let's try white. Let's see how it goes. Okay, so because I use that for an eraser, but I think that'll be okay. All right, so I got that as 9 centimeters. Okay, and then I came up here and I tried to find somewhere where I could see how long the blur was, and I found the blur to be from like there to there, and I found that to be 1.5 centimeters. So then I thought, okay, I said, what's the size of the blur relative to the width of the sidewalk? What's the size of the blur relative to the width of the sidewalk? How would I find that? Relative size. How do we compute relative size? Division. What? So I want the blur relative to the width of the sidewalk. Someone put that in your calculator real quick. Tell me what that is. 8.1? No. That can't be 8.1. That's 1.5 over 9. 0.16. Give me one more. 6 is repeating? 0.167. So the blur is 0.167 of the sidewalk. Make sense? So that's the size of the blur relative to the size of the sidewalk. Or the crosswalk. What is the actual width of the crosswalk? 10 feet. So if this is the width of the blur relative to the crosswalk, which is 10 feet, then how truly wide is the blur? 1.67. Yeah, so I want 0.167 of 10 feet. Relative size. This is the size of the blur, the width of the blur, relative to the width of the crosswalk. So if my crosswalk's 10 feet, I want that relative size of 10 feet, which would be 1.67 feet. That would be using the relative size reasoning that we talked about in class to do this. Does it make sense? So look, so as we learn these ideas, it's probably most of you come out of class and you get it. It makes sense. But then we want to take it a step further and get it embedded in the system so that we can be on the lookout for ways to use it, so we can really apply it. Okay? Rather than maybe reverting back to rules. How many people set up a proportion and cross multiplied? It's okay. Okay, so not many, okay, or not admitting it. All right, that's okay, that works. But the problem is that when the situation is slightly different and that doesn't work, then what are you going to do? So the thing about working by reasoning is if you can be adaptable, right? If something changes a little bit, you can still solve the problem if you can use reasoning to do it. Okay, so this is 1.67 feet. And so then in the second thing, using this, how do we find the speed of the truck? And I said use an illustration, so 1/40th. So my hope to apply what we've done in class was that you said, okay, well, let's look at 1 second. And what we want to know the distance that the truck went in 1 second. And what do we know?
1/40th of a second.
We know that in 1/40th that second, we just figured out that the truck went 1.67 feet. And so what is 1.67 feet relative to the distance traveled in 1 second? It's also 1/40th, right? So in 1/40th of a second, that's 1/40th a second is 1/40th of 1 second. So the amount traveled in 1/40th a second is 1/40th of the amount traveled in 1 whole second. So we're going to do 1.67. So we can think of it as divided by 1/40th or 1.67 times 40. Crank that out. What's that? 66.7 feet. So is that a distance or a speed? 67 feet. Is it a distance or a speed? It's both. Why is it both? Yeah, because it's the corresponding distance for 1 second. So it's both. So the whole reason we set this up to be 1 second, so that this distance traveled would be our speed. That's our speed. It's how many feet you go in 1 second. You see? Okay. Any questions on the front side of this exercise? So you see how everything I did there was using the reasoning that we talked about in class. If you did something slightly different, it's okay. But just always be on the lookout to practice what we're doing in class. Other questions? Any of the notation stuff that you want to ask about? The function notation. Really important.
Do you want about just figuring out the time? Like,
Okay.
I don't remember which one it was. It was like C or something.
The time
Like right
from the street light to the
end of the
when the shutter closes. Okay, so in this first example with the green truck, the green SUV, it said it was 38.2 seconds from when it passed the street light to when the shutter opened. So that's just asking for an expression of time from starting at the street light to when the shutter closed.
So is that just like 38.2 plus 1 over 40?
That's it. Yeah. Yeah. So it's 38.2 is the time from passing the street light to the shutter being open. So then the time from the street light to the shutter being closed would be another 1/40th of a second. So that would be that expression. Okay. Any questions? All right. So hopefully you brought your laptop and you've got graphing calculator loaded up. So if you don't, hopefully there's someone close by. So those with laptops, you might need to share. Everyone should be able to see, hopefully see a screen. When you open up Graphing Calculator, you should see a window like this. Do you get a window like this? Don't do anything yet. When you open up Graphing Calculator, you should get a window. Okay. These, the color square there, this is a command line. Okay, so this is where we're going to put the commands in. And the commands are, they're not commands that are instructing the, you can't think of them as commands that are instructing the, let's get there later. Okay, so we're not even there yet. The first thing about Graphing Calculator is that it's a very powerful just calculator. It just can calculate things very easily. So 5 plus 7. You don't even have to enter. You just type in 5 plus 7 and there's the answer, 12. Okay, so I can change that. I can say divided by 4 and it just keeps changing the final answer on the fly. Okay? Pi. So here's 5 plus 7 over 4 pi. Answer 5.55704. Okay, so then you can go in and edit that. You can copy and paste. Say I can copy that and add, 5.6 times that again and paste. So you have all the features of an editor just like a word processor. As soon as it sees a valid expression, it's gonna take that. And as you change it, it'll keep changing the answer.
How did you do pi on your last one?
Oh, so all you have to do is do pi. Just pi, and it'll change it to pi. Okay, square root. Say I want to take the square root of this whole thing. So I could highlight the whole thing. On a Mac, Option V. Option V. Lots of times on the PC, it's just, instead of option, it's control. So is it Control V? Does that work for square root on PC? Alt?
Try Alt.
Okay, so for keyboard shortcuts, the first place you can go is Control Shift R. Control Shift R on PC. So some real basic shortcuts are in the math. If you go to math menu, okay, if you go to the math menu, it'll show you some keyboard shortcuts. I'm not going to be able to teach you everything. All of the keyboard shortcuts, if you go to Help and then go down to Keyboard Shortcuts, you get a window that lists them all. Supposedly. There it is. Help, Keyboard Shortcuts, gives you a window that gives you all the keyboard shortcuts for all. So I'm not going to be able to go through every single command that you're going to need. So some of this you're going to have to just poke around and figure out for yourself. But we'll do as much as we can together. So just to get warmed up here. All right, let's see how good of a circle I can make here. Not the worst. Okay, so suppose this is 28.6 and 21.32, and then this height over here is 15.17. So use Graphing Calculator to write one expression Okay, so to get a new, all right, one thing at a time here. To get a new command line, you're going to hit Command Return on Mac. And is it Control Return on PC?
Yeah.
Okay, so just hitting Return is not going to get a new command line. You need to hold down the command and hit Return, or Control and Return. On this new command line, what I want you to do is find the area, write one expression, one mathematical expression that will calculate the area of the red shaded region. Okay? This is a trapezoid with base 28.6 and top base 21.32 and height 15.17. Write one expression so that it shows the area of the red shaded region. Go. Okay, don't work on this until given instructions to do so. So just hold this off to the side.
So it'd be minus 9 r squared, whatever that is. Well, that would actually not give you the circle area, that would give you the area. Or no. Hold on. Yeah, that would give you the red line area. You're subtracting the circle.
Yeah, highlight it and hit left parenthesis, and it'll do it. If you want to put parentheses around something you've already typed, just highlight the whole expression and then just hit left parenthesis, and it'll do it. When you hit left parenthesis, it actually always gives you both. It gives you both parentheses. Hold off on the handout. Just don't read the handout. Yeah. Do this.
Diameter over 2. Well, I guess you could. So what's in half of 15.17? Because that would be a radius. 7.585. 5.855. So do that, and that will give you a red outside. And I guess you could plug in numbers for this, right? Is that what you want to say?
So for those who forgot, area trapezoid. There's the area of a trapezoid, so that might help.
I'm looking for the circle or the red circle.
The red shaded region is the area you want.
Okay.
Yep. Does everyone see a screen? Is everyone able to see a screen?
Oh, 7.585 squared. Did do carrot.
Okay. Because I don't want to raise it off. Alrighty, cross the line. I'm gonna have to do one more.
Okay, so for square and cube, all you have to do is shift 2 or shift 3. Those are built in as the exponents. So shift 2 just automatically gives you square. Shift 3 automatically gives you cube. But any other exponent, you have to do shift 6 first, caret. So shift 6 first and then your exponent. But 2 and 3, you can just do, I just do shift 2. I got 197.9. 197.9. So, let it do everything for you. Don't get out a handheld calculator and do 15.17 divided by 2, right? But it'll do all of it for you. So, this will do everything a TI will do 100 times more and 1,000 times better. Okay? So, if I can really encourage you all semester long to use this instead of a calculator, you'll start to appreciate it a lot, okay? Especially since you got it for free, okay? Questions on the area problem? Getting that set up. Everyone okay? So now your next exercise here, solve for x. How do you do that? It's your favorite formula, right? All over? That's not 6, that'd be.
Plus or minus.
What's up?
Plus or minus.
Well, yeah, so what would, I mean, can't do that. It can give you the value of one expression at a time. Also for fraction, if you already have an expression and you want to divide the whole thing, you can just highlight it and hit divide, and it'll just put the bar on the whole thing. Okay, so watch, you can, this is really helpful, you can just highlight the whole thing and then just hit divide. For the plus solution, I got 0.878. Did I make a mistake, or did you get the same thing?
Negative in front of the, or I guess it doesn't make a difference.
In front of the what?
For the net, the b squared.
Yeah, so to be precise here, so if we can highlight that, left parentheses. Anybody need help?
Nope, I don't need it.
You're good, you're good? Right there. Okay, so this is just going to calculate one expression at a time. So you're going to have to adjust for that. Right? You're putting in expressions. It's going to crank out one value of that expression. So what does plus or minus imply?
Or no, for root was, on your guys' segment, you have a map. It was control. He's got the square on the outside.
But you can always go to the map up there and then highlight it and
Oh.
go up. Thank you.
What?
You could just go to the app and select. Either yeah, you gotta take that into the computer, or you can just go to the app and select it. Yeah. Other questions? Yeah. Yes, sir.
Yeah.
Let's go.
I have yet to learn
Maybe, I'm not sure though. So, am I going to type that whole thing again to get the minus version?
Nope.
What do I do?
Change it to a minus.
So, two choices. You can just select it and change it to minus, and boom, there's the other solution. Or, what else could I do? Yeah, just copy the whole thing, start a new command line, paste it, and change it to minus. Any questions up to this point? If you just force yourself to use it instead of that habit of grabbing the handheld, you're going to start really appreciating just as a normal calculator. Okay, so this handout is, again, calculating a formula for mortgage payments. So the amount of your payment is dependent on the interest rate and the initial amount of the loan and the number of payments. There's the formula. So let's do the first one together. So what is it? The first one would be 0.06 divided by 12. What's P? 250,000. Okay, times 1 divided by 1 minus 1 plus. What's R again? 0.06 divided by 12, and then in the parentheses. So again, if you have an exponent of 2 or 3, you can just do shift 2 or shift 3, but any other exponent, you just shift 6, and we want minus, what's n again? 180. And that should give us a payment. So if your interest rate was 6% on a loan of $250,000, you want to make 180 payments, the payment would be, let me make this bigger, 2109. Everyone able to do that? So you're going to finish this table. Finish this table. Practicing using everybody with me? If you have a question, let us know.
I have a question.
Yes, sir.
How did you get to
So you do the exponent, you do caret, shift 6. Gives you an exponent.
Does it matter that my bracket is you gave me the same answer.
Oh, I mean, mine is saying take this times that fraction. Yours is saying what? Take this times that fraction. Yeah, I mean, it'd just be like putting parentheses around this. That doesn't change anything, because it's multiplication. Was there a hand back there? Did I see a hand? Okay, finish the table on the handout that I gave you, okay? Hold off on this new handout.
Are you gonna write something? Do you want scientific notation?
Oh, we'll talk about, yeah, talk about that in a second. No, so you want your payment amount. You would, so a dollar amount, you wouldn't say in scientific notation, right? You'd say it's a dollar amount.
Okay.
Keep working on the first sheet. Keep working on the first sheet.
This is monthly payments.
Yes. Well, no. It's a payment for whatever your n is counting. Yeah. No. Yes, it is because it's divided by 12. You're dividing the rate by 12. So yes, they're monthly payments.
Why is it this one is 1 point? I got 1.87. Oh, it's okay. How do I expand this here? Just
Okay, I want to talk about the fourth. Go ahead. The fourth one. The fourth one. Did you get to the fourth one yet?
Yep.
This is what you see.
Yep.
Okay, and this is exactly what your handheld does too. So what does the E mean? It means scientific notation. It means take this number and do what?
multiply it by
Move the decimal 7 places.
Okay, so literally it means 1.871, I'll round to 1718, okay, times 10 to the 7th. That's literally what this notation means. E means exponential or scientific notation. So times 10 to the 7th, which some of you said, means move the decimal place. You're going to multiply it by 10 7 times. So it's going to be 18. Is it 18 million? One, two, three, four, yeah. So on a $2 billion loan with an interest rate of 2.35% and 120 payments, each payment is 18,718,000.
Yeah.
So you think that a $2 billion loan is impossible? Our country has an over $16 trillion loan. Much, much bigger than that. So we'll be making payments soon. All right. Questions on the table? We're going to move on to the next thing. Any other questions on the table? Okay, so how about this for efficiency? Making this table this way. Efficient? I mean, yeah, using the software is certainly helping. But we could do a lot better. The software can do a lot better for us. And that's by what's called parameters. We can define parameters, which are letters that stand for values. Okay? So what we can do is, are there any extras of the, I'll figure it out. So we can say, just type capital P. So what you see is, immediately it says equals 1. What that means is this is a free parameter. We can use it to assign values to it. And with having not assigned anything to it, it just starts at a default of a value of 1. Okay? So in the second handout, in the first row of the table, what is the value of P? 26, 260,000. Is that right? So now we've told the program that we want capital P right now to be 260,000. Okay, start a new line. What's next? R. In the first row of that table, what's R? You're on page 2, right?
0.0625.
Are you on page 2? 0.0625. Okay, then use capital N for the number of payments. What is it for that first row?
360.
360. Okay, so you can use parameters to actually assign values, or you can use parameters to set up an expression. So we want to set up a parameter called payment that's going to be the formula for our calculating the payment. So you can use character strings or more than one letter to represent a single value. So is everyone tuned in with me? Because this is a question that students always have, like in a couple days or a week. So stay with me here. If we want to use the expression PMT, just to be one constant, one parameter, you're going to start with backslash, which is over on the right side of your keyboard above return. Is that forward slash or backslash? That's backslash. That's backslash. Okay. Backslash. Now type in PMT, and then backslash again. Is everyone getting this? This was a question last semester. Students didn't pick the first time. And when you hit that second backslash, notice what happens. It creates it as one entity, one parameter, and now it's set equal to 1. Open a new command line and just type PMT and see what happens. Oh, no, it doesn't work. We already did it. So type cheese. What is it doing here? What is that doing? Is cheese one single thing? No. What is it?
C times H times E times E.
It's a multiplication. It's C times H times E times E times S times E. You see that? And so it's multiplying those together according to their current values and getting this product. But if you do backslash cheese backslash, then you can make cheese be one thing, one parameter. So backslash cheese backslash. Now that word is one value, and it's not a product of 5 things. Doesn't make sense. But we want this PMT to be our formula. So we can go here, back to PMT, and say equals capital R. So now we can put the letters in, right? We can put the letters in. R divided by 12 times P. Is it the same formula as the previous sheet? Times 1 divided by 1 minus 1 plus R over 12 to the, did I get it right?
Yes.
Is that correct? So now all we have to do, go into the next line and do P. So now from here on out, as you saw, you don't have to put the backslashes anymore. Once you've defined it as a single parameter, all you have to do is type PMT, and it knows that that's that one thing. So go to the next line. Do PMT, and lo and behold, what do you see? What did it do? It took the formula and all the current values of R, P, and N that we defined here, and it cranked out the value of the formula. So this table should go a lot faster, right? Because all you have to do is to do the next line is do what? Just go to these 3 and change the values, and then look right there. It should automatically change. Go. Oh. Yeah, you did it for all of us. Yeah, you have to have equals. Yeah, that's what happens. It's gonna have equals.
Question.
Good.
What's the difference between just PMT value and just
No difference. You just didn't define PMT. It could be anything. So that works perfectly fine too. But like later, if you want another formula that you wanted to have that payment as part of the formula, you'd much rather have PMT.
PMT.
Yeah. Questions?
It's the same. The last one on here is the same as the last one. Hold on a second. Same. Let me try to recover the rest of my pen. Why did that happen?
Okay, so I'm gonna hand quizzes back, but please try to stay focused on the task at hand and maybe look at these later, okay? So, where's Jacob? Kaiser.
The quiz that we took in the last. No, sorry.
Peter Collins.
Oh, this is the easy one. Okay, hold on. It's telling us a different way of doing it. Copy this though, because I don't want to.
How are you?
Start on the new one, right?
Tyler. B. Tyler? Or Tylea, maybe Tylea?
Tyler.
This is Tyler. Tyler D. Yes,
Can we do the back page?
I'm going to get to that in a second. Yeah, you can start reading that if you're ready. Samantha. Heidi.
So it says control.
Henry. Daniel. Matt. I'm coming. Keep working. Hanku. David Lee.
Like, 303894.
T. Lee.
53971. 1.87
Andrew Look.
and 17178.
Hanley. Forgot to put your total grade down too. So we're C. Lee. Martin. Last name Martin. Katie Maxey. Megan Akria. Marcus. Katie. Thru, can't read the last name. Okay, I'm going to hand out the rest later. So even better than this now. Okay, so can I have your attention? So do you have some success at this table, doing it this way? Even better than this is to use the function notation that we've learned. Graphing calculator can do functions just like the notation we learned last time in class. So here's how you do that. So suppose instead of just calling that formula this parameter, we can set up a function. Let's name it f, just because that's the most common name. Now, here's the key. To get the parentheses for the input, when you're doing a function, it's not shift 9. It's not just left parenthesis, because that'll think it's what? Multiplication. If you do shift 9, it's going to think f times whatever's in there. So to get function notation input, you want control 9. Control 9 also gives you parentheses, but tells graphing calculator, oh, we're setting up a function, and these are going to be our inputs. Okay? So, in the last table, on the page 3, first line, what is P, R, and N? Oh no, I'm sorry. So we need to set up the function. So we need to tell it how it works. So we're going to do P, comma, R, comma, N. So we're telling graphing calculator that our rule for the function f is going to have 3 inputs. 3 inputs. It's the same rule that we had before, so we can just come down here and copy and paste. So now I've just defined the function called f with 3 inputs, p, r, and n, such that whenever you invoke the function, it's going to do this rule, this operation, on whatever you put in for p, r, and n. Yes, sir?
Do you make the function equal to the phrase PMT and then carry over to the, or do you actually have to return the entire function?
Maybe. But, so if we were using function, we wouldn't have had this in the first place. So it's because, so maybe, you can experiment with it.
Yeah.
But normally when you define functions, you're going to write the rule there. You're going to put the rule there, okay? So now we want to use the function. So start a new command line. And you do f, again, control 9, not parentheses, but control 9. And what's the first row in your last table there on page 3? What's the p value? 200,000. So we just told graphing calculator that that p value is going to be 200,000. Then what? 0.16. 180? Okay, so this is yet the most efficient way to go about it, is to use function notation. Function notation is not just a reason to have math class, okay? It's a very powerful tool that allows us to do a process over and over again very efficiently. It's going to be the same process every time, so all we want to do is change the input. Okay, so in your math career, this is just something that whenever you need to do something over and over again, and it's basically the same but just a little different, hopefully that calls to mind, oh, that's the idea of a function. I can use a function. Okay, what's the next row on the table? 980,000. 0.0425 and 360. So this is yet the most efficient way to do this type of exercise, to use function, okay? To use function to do this repeated process over and over again. So you define the function, and then you invoke the function then by putting the values in for P, R, and N. Okay, so there's a homework assignment. We'll continue with this stuff. Bring your laptops again Friday. We'll start graphing on Friday. Okay, start graphing on Friday. There's an unrelated assignment that's based on more readings. So you're going to do more reading, and then you're going to do some more writing reflections based on the readings from Friday. Okay? It's posted on Blackboard. I have the rest of the quizzes. Adelaide. Lauren.
Like the challenge. Is the challenge problem?
No. There's no, the in-class sheet is not one. Elsie Roger. The in-class sheet won't get turned in ever. That's for you to keep. Laura and Ryan. Cindy Salgado.
They all see that out. Why would we want to?
1 second.